Welcome back to Johnson Chapel. We welcome you for what I think qualifies as the first academic event of orientation. Do not be fooled. Amherst is not going to look like this week after this week. I'm delighted to see you all in squads, having those serious conversations. I know you've all been getting to know each other, getting to know the college. We can feel the energy building. It's great to have you all at the house. And I look forward, I know everyone at the college looks forward to continuing to build the momentum. Tonight we do so with the DeMott Memorial Lecture, named for one of Amherst's great faculty members. Ben DeMott was a member of the English department here in the chapel for around 40 years, a prolific author, a major public intellectual, a major force at Amherst, a major force in the United States of America and beyond. I recommend his readings to you. I also want to take this opportunity to thank our sponsor for the DeMott Lecture, who's here with us tonight, Alan Levenstein, who graces us, and we're grateful for your support. Tonight's speaker is a great treat for all of us, and an honor to have him back, as always, and anytime at Amherst. Harold Varmus grew up in New York. Not much New Yorker reaction for that. And arrived at Amherst College in 1957. Keep that date in mind as we go forward. Expecting to be a pre-med, Harold instead became an English major. Wowed by the amazing English faculty here, he did not take the direct route to the profession that he anticipated. And we hope that one of the lessons for you tonight, in addition to the inspiration of his words, will to think about what it means not necessarily to follow the path you anticipate at this moment, to be open to what Amherst opens for you and in you. Harold Varmus went on to earn a master's degree at Harvard in English, and only then to go into the sciences at Columbia for graduate work. And in that combination, he has proved in his career that going broad and varied and unexpectedly before going deep can provide greater outcomes than anything else. Harold Varmus has described himself as only going seriously into science at the age of 28, but it has been fairly serious since then. He spent 23 years on the faculty of the University of California at San Francisco Medical School, finding his research partner, Dr. Michael Bishop, and together working on the isolation of genes that control the growth of cells, a key ingredient in understanding the dynamics of cancer. For that work, Harold Varmus earned in 1989 the Nobel Prize. In 1993, he was appointed director of the National Institute of Health, and in 1999 he became the president of the Memorial Sloan Kettering Institute and Hospital Complex in New York, the premier cancer research and treatment facility in the world. He continued there, as he continues now, to have his own research lab, has produced more than 300 academic papers, continuing to today. While doing that, and shall we say on the side, administration of the public service and of private institutions, a fundraiser and a visionary of world renown. He has been a public figure and public intellectual in issues about macroeconomics and health. He's been a leading force in the open access of scientific journals to make it possible for you all and everyone around the world to have access to information, to use the new technology that we all have at our disposal, not to control that information, but to make it more accessible. He worked closely with President-elect and then President Obama, and has now been appointed as the director of the National Cancer Institute. Harold Varmus is the author recently of a powerful book, The Art and Politics of Science. It tells you something about Harold Varmus that he did not assign his own book today.
Foolish.
No, that isn't what I had in mind, Harold. Instead, he asked you to read a book that would lead you to understand the connections between imagination and scientific inquiry, to see science as a relay race, a partnership of unexpected ideas inspiring unimagined thoughts. Two pieces I'd like to quote from the book, both from the chapter Herschel Among the Stars. One is from page 203, Herschel considering the idea from his own work that deep space must also imply deep time. Thinking ahead of Einstein by a century, to understand that when you look into deep space, you're looking into deep past, and that time and space are a continuum. Or the other quote, also from that chapter, is the visit by Byron, who comes to Herschel and looks through the telescope and has what is described as an alarmingly religious experience. Byron writes, "I did not expect that because I doubted the immortality of man, I could be charged with denying the existence of a God. It was the comparative insignificance of ourselves and our world that he only saw by looking through that amazing instrument. When placed in competition with a mighty whole, of which our world is but an atom, that first led me to imagine that our pretensions to eternity might be, in Byron's words, overrated. I will let you make your own judgments about eternity. But I know you will come away from this evening inspired, as we at Amherst have been since Harold Varmus was here as a student, to understand the combinations of imagination and scientific inquiry and the poetry of that combination. It is a great honor to have Dr. Harold Varmus here today.
Thank you, Tony. You can see the president's done his reading. That's impressive. So, first years, not freshmen, first years, welcome to Amherst College. Once upon a time, believe it or not, undergraduates were required to attend morning chapel meetings here at least twice a week. So I spent a lot of time in the uncomfortable seats that you're now in, and let me report that the view from the podium is better than the feeling you get in those hard seats. And I'm very pleased to have a chance to speak to you from this podium on this important occasion in your lives. Now, I know that some of you were perhaps surprised, maybe disappointed that your undergraduate careers would begin with a summer reading assignment to prepare for this lecture. A friend of mine happened to see the following tweet on the web, and I quote, "My college sent me summer reading. I was sad. Then I found that it's because a Nobel Laureate alum is speaking at orientation. Now excited! Exclamation point. Signed, Geek with a smiling thimble." So I'll try not to disappoint geeks or anybody else. As you've heard, this talk honors the memory of Benjamin DeMott, an extraordinary member of the English department at Amherst and an influential observer of American culture, a man who died in 2005. I knew him well. I was a devoted student in two of his courses, one on 17th century poetry, another on modern British fiction, and I enjoyed numerous chats in his office. I'd like to mention briefly three disconnected and idiosyncratic recollections of his influence on me. First, when he recited the famous passage from Milton's Paradise Lost that describes the expulsion of Adam and Eve from the Garden of Eden, he wept. Sensing that the class was unsettled by this display of emotion, he explained that the passage reminded him of his young children playing in a sunlit garden and of their eventual need to grow up and leave the garden. We were jolted, I think, Peter, you may have been there as well, and touched by this incredible connection between his life and the literature he read. A second item, when DeMott's first novel, The Body's Cage, appeared, I dutifully bought it and asked him to inscribe it. I'm not sure what I hoped for in that inscription, but he wrote, "For Mr. Varmus, my favorite door closer." Now, it's true I often sat near the door, and I often closed it before class began, but I find that actually I still find, when I think about this inscription, that the intent was intriguing and mysterious, ironic perhaps. I'm not quite sure what it meant. Third, and less ambiguously, one day he read aloud to the class from my assigned essay on Henry Green's novel, Loving. Probably unknown to him, I was thinking at that time about giving up my interest in medical school in favor of graduate school in English literature. And his small tribute to my essay made me think maybe I could be successful in a field I really hadn't thought much about before arriving at Amherst. Now, I tell you these odd remembrances to illustrate how memorable the words and opinions of a great teacher like DeMott can be on impressionable students, which all of you now are, I hope, especially at a place as intimate as Amherst College, where students and teachers actually get to know each other. The memories of DeMott are also related to my overarching ambition for this lecture, to say on the occasion of your entry into college that despite all your guidance counselors and the aptitude tests, we really don't understand how lives take shape or how careers are formed. When I asked you to read about William Herschel in Richard Holmes' wonderful book, The Age of Wonder, and now in speaking tonight about Herschel's life and accomplishments, I will be touching on some of the things that you've come to college to learn, things that I also came here to learn some years ago. What interests me? What gives me satisfaction? What are my real talents? And how am I going to develop and use those talents? As you all now know, if you've read some of the assignment, you know that Holmes was writing about the Romantic Age, the period between 1770 and 1830, a time of great intellectual ferment in Europe in both the arts and sciences. And although barely mentioned in his book, the American and French revolutions were also profoundly changing political history. More to my purpose tonight, the Romantic Age was also a time when cultural life was much less highly categorized and specialized than it is now. Still, as I hope to show, many of the things that Holmes tells us about the Romantic Age have resonance in our own very different times. Consider our hero, William Herschel. Trained as a musician, renowned in his 20s for both his oboe performances and symphonic composition, he ultimately became the most important astronomer of his day, the first person in over 1,000 years to find a new planet, the source of radical new ideas about the universe, a brilliant fabricator of powerful telescopes, an explorer of the skies who's still honored today by the naming of new telescopes that are on land and in space. But he was also distinctly an amateur, largely self-taught, driven by his own curiosity about our galaxy and about galaxies beyond, helped enormously by an intriguing and amazing woman, his sister, another amateur, who became famous as a discoverer of comets at a time when it was exceedingly rare to find women in science. Now, in the Romantic Age, science was not really a distinct profession. Scientists were called natural philosophers, if they were called anything at all. And as Holmes points out in a footnote, the term scientist didn't officially enter our vocabulary in the Old English Dictionary until around 1840. Funders of research were royalty or the rich, not universities, public institutions, or governments. The study of natural phenomenon had been recognized in Europe as an organized entity for only about 100 years. There were indeed older traditions in China and in Islam. In England, where Holmes' story largely takes place, the Royal Society of London was the focal point for this notion that science could be a communal function. The society was founded in 1665, just after the restoration of King Charles II, by enlightened people from all spheres of life, from the arts, from government, from the legal and medical professions, from the aristocracy. People who enjoyed observing experiments, which were often performed in the Royal Society's buildings, or learning new information about the Earth, its life forms, and the stars. The leaders of the Royal Society, especially its long-term president, Joseph Banks, who you can read about if you read some of the unassigned chapters from Holmes' book, those leaders were willing to listen to anyone who shared the interests in science and showed aptitude. So a German musician, like Herschel, living in a provincial town, like Bath, might quickly come to the attention of even the astronomer royal if he set up a homemade telescope in the street for celestial viewing at night and had an unexpected encounter with the son of a member of the Royal Society. So how did it happen, this pivotal encounter that opens the first chapter that I asked you to read? And what then brought Herschel to his moments of scientific glory? William was born in 1738 in Hanover, a place that's now a city in Germany. He was one of 10 children in a musically accomplished family. Taken from school at the age of 15, he joined his father and an older brother as members of a military band that played, among other places, in England, thanks to the tight familial bonds between the rulers of Hanover and England. William was instantly enamored of English ways and culture, and he learned the language and came back to live in a series of English towns where he was offered a succession of musical posts, culminating in 1766, at the age of 28, with an appointment as organist and musical director in the fashionable town of Bath, many hours west of London. Now, some of you may have gotten the impression that Herschel was just a journeyman musician, but I'm going to give you 2 minutes and 40 seconds of evidence against that. So you've just heard part of the first movement of one of his oboe concertos. It's terrific. It testifies to Herschel's skill as a performer as well as a composer. Now, of course, he lived too soon to be recorded directly. That's not him. But he was nearly alone among musicians of his time in writing out his cadenzas. So we know the difficulties of what he was trying to play as a soloist. And having been an amateur oboist myself as a young adult, I know how hard these passages are. I would never attempt one of them in front of this audience or any other. While exercising his great musical talents, Herschel was also reading the best available texts on mathematics and astronomy. Years earlier, his father had fostered William's interest in the constellations and introduced him to the popular writings of James Ferguson, an early 18th century Scottish farmer who also taught himself to become an astronomer. At the same time, William was also learning how to make reflector telescopes, the type advocated by Isaac Newton a couple of centuries before, so that he could observe the night sky directly. Herschel's growing obsession with astronomy brings me to my first and perhaps most important message of the evening. Talent and training in the arts or the humanities is not a barrier to the successful pursuit of science. Just as he traveled from music to astronomy, Herschel had also traveled from Hanover to England. He was an immigrant, driven by curiosity about many things, undaunted by boundaries. And this is a continuing tradition in modern science. Many of the best scientists in America today, fully 1/4 of the members of our own National Academy of Sciences, were born elsewhere. I know many of you in this audience were born elsewhere, and you should remember this. Those scientists who've succeeded in this country were not deterred by the barriers of cultural differences to get themselves to places where science is respected, supported, and done well. Now, Herschel was skilled technically, not just intellectually. That talent may have helped him to shape his oboe reeds from bamboo cane. It certainly accounted for one of his most memorable accomplishments, the construction of telescopes of increasing size, starting with a few feet, a 7-foot scope he had on the streets of Bath, to telescopes of over 40 feet with perfectly polished mirrors that were over a meter in diameter. These telescopes gave him unprecedented power to penetrate the night sky and to perceive new objects. Most famous of these was a new planet. Most profoundly were stars in all stages of development. We'll come back to those in a moment. And as is true today in all fields of science, improved technology was the key to his new discoveries. And is also true today, improved technology is often expensive. So from that monetary perspective, Herschel's famous nocturnal meeting with the young William Watson on the streets of Bath in 1778 was much more than just quaint. It led swiftly to a correspondence with the Astronomer Royal in London, to papers that he published in the Proceedings of the Royal Society, to audiences at the royal court, and finally to the patronage of his king, George III, the enlightened and, yes, witty man who was also the enemy of American revolutionaries and ultimately the victim of a brain that was deranged by metabolic disease. King George bought many of Herschel's expensive telescopes, and he funded Herschel's plans for telescopes as large as 40 feet in length. These days, of course, we turn mainly to our governments or to our great foundations or our wealthy board members, not to royal families, which are often impoverished, for support. But that support is still essential, as I'll remind you before we are done. For Herschel, as for all of us today, money, methods, and ideas are not enough. We need co-workers and assistants. Herschel found the best possible helper when his adoring, diminutive, brilliant younger sister Caroline eagerly left Hanover in 1772 to try her luck as a vocalist with William's musical group in Bath. She had a highly promising start and was offered an opportunity to perform in London. But she was persuaded by William to repudiate that offer in favor of assisting him with his astronomical observations. One might consider that self-serving, and maybe it was. As we learned from Holmes' admiring account of Caroline's life, her brother did not treat her very well, at least by modern standards. And those of you who've read the assignment will no doubt recall the time that she was physically hooked on a piece of equipment and ignored by her brother who was trying to make an astronomical observation. But she did learn astronomy, and much later became known throughout Europe for her sensational discoveries of several new comets. Nearly alone among women of her time, Caroline dramatized the capacity of women to master even very difficult scientific methods. Surprisingly, this notion is still occasionally challenged today, even when we have so many more examples of women who have been enormously successful in so many fields. And I trust the women in this class will not be deterred by the notion that historically women have had difficulties in science. Now, unfortunately, in early March of 1781, Caroline was not at her usual place at the other end of the telescope recording her brother's observations when he had his most famous moment. Close on the evening horizon, he sighted an object that proved to be a new planet, now called Uranus. As Holmes emphasizes, the story of this discovery has been simplified over the years into a simple eureka moment. But in fact, several more nights of viewing by both William and Caroline, confirmation by others, including the Astronomer Royal, deductions based on experience with comets, planets, and stars, and calculation of the orbital movements of the new object were required for them to conclude that it was a planet rather than a star or a comet that they had found. And this, of course, is the way that science usually works. Herschel took the discoverer's prerogative to propose that his new planet be named Georgium Sidus, or George's star, to honor his patron. But this name was unpopular with the French, who had no love for the English king. Finally, an international compromise was reached to name the planet for Urania, the goddess of astronomy. Uranus was then the outermost known planet, and its orbit enlarged the volume of our galaxy by twofold. Just as the public's conception of the universe changed, Herschel's cautious process of observation and deduction was also condensed in the public mind into a moment of eureka. And in this way, the discovery became even more romantic and inspirational than it was inherently. Nothing displays the symbolic significance of this discovery more than a remarkable poem by the young poet John Keats that was written 35 years later in 1816. Keats was then only 20 years old, not much older than most of you, and he was a medical student at a London hospital. After a long night with friends, joyfully reading a translation of Homer's Iliad by the 17th century poet Chapman, Keats dashed off in less than 4 hours a sonnet that compared the evening's revelation of great poetry to the discoveries of astronomers and explorers, moments in which, as Holmes says, quote, the geography of the earth or the structure of the solar system are in an instant utterly changed and forever. Let me read that poem to you on first looking in Chapman's Homer. Much have I traveled in the realms of gold, and many goodly states and kingdoms seen. Round many western isles have I been, which bards in fealty to Apollo hold. Oft one wide expanse had I been told that deep-browed Homer ruled as his domain, yet never did I breathe its pure serene till I heard Chapman speak out loud and bold. Then felt I like some watcher of the skies when a new planet swims into his ken, or like stout Cortez when with wondering eyes he stared at the Pacific, and all his men looked at each other with a wild surmise, silent upon a peak in Darien. Herschel was made famous at the time and is best remembered today for that new planet swimming into his ken. But in Holmes' account, Herschel impressed me more by his revolutionary conception of the universe, something that Tony Marks referred to in his opening remarks. The conventional image of our galaxy that's seen even today in some planetaria shows the sun and orbiting planets inside a larger orb that's studded with fixed stars of various sizes. But Herschel's universe was dynamic and of uncertain, unthinkable vastness. He envisioned our galaxy moving through three-dimensional space, and that deep space was punctuated with stars that were in various phases of development, as gaseous condensations of early stages of star formation, as mature stars, and as stars entering extinction. He viewed the universe, as Herschel wrote himself, as a luxuriant garden which contains the greatest variety of productions in different flourishing beds, resembling germination, blooming, foliage, fecundity, fading, withering, and corruption of a plant. Herschel also realized that stars that seem small to us might actually be extraordinarily large, but at great distances. Distances so great that the stars might be gone by the time the light reached here on Earth, an idea that long preceded any careful calculation of the speed of light. Herschel changed the way we think of our place in the universe, or paved the way for that change, even more profoundly, in my view, than Copernicus or Galileo. Of course, not even Herschel got everything right, and Holmes takes amusing note of the beliefs by Herschel that there were forests or other creatures on the moon, that life like ours was possible under the surface of the sun and on other planets. Now, deductions and conjectures by a great astronomer about the composition and function of the universe remind us that astronomy is somewhat different from other sciences, more dependent on observation than experiment, more closely tied to theology and philosophy than to the practical arts like medicine or manufacturing. Astronomy was probably man's first science. Changes in the moon and the stars on a clear night in a non-illuminated world would have been an irresistible object of curiosity, providing to early man ideas for myths about our origins and ideas for gods that control our fates. Yet by the 16th century, astronomy had also become a very pragmatic discipline, especially for a nation like England, with its sailors and traders that depended on navigation that was guided by the sun and by stars. Indeed, in Herschel's own century, many astronomers had responded to a royal offer of a prize for a reliable way to determine longitude while at sea. And as we've seen, success in astronomy had become a source of national pride and a prized symbol of royal power. Now, at this point in this lecture, I could recall with pleasure much more about Holmes' account of his extraordinary astronomer, Herschel. Herschel's discovery of infrared energy and planetary moons, his grand parties inside that 40-foot telescope, which itself actually was never very productive, his marriage and its unfortunate consequences on Caroline, his difficulties in providing career guidance to his brilliant son. But instead, before I give Ben DeMott the final word, I would like to turn briefly to another story, one that links Herschel's transforming view of the heavens to a freshman, I say freshman, Amherst was then all male, freshman's arrival at Amherst College at the time of another transformation of the sky. I was that freshman. My mother dropped me off at 302 Stearns Hall in early September 1957. A few weeks later, on the evening of October 4th, happened to be my sister's birthday, I learned from gossip and from the radio that the Soviet Union had, for the first time, placed a man-made object into an orbit around the Earth. This was the satellite called Sputnik. At that moment, a new heavenly sphere, a kind of mini-moon, was circling the Earth, supposedly visible in the night sky, issuing a detectable rhythmic signal, allegedly in the key of A-flat. Late that night, I went out of Stearns Hall and onto the quad, but I actually couldn't see or hear anything unusual. But I believed what I heard on the radio, and I just needed Herschel's telescope to see it. Although still in earthly orbit, not really very far away, and not expected to pose any direct danger to us, Sputnik had an enormous impact. Americans were then preoccupied with a Cold War against the Soviet Union. And for most of us, Sputnik was a frightening development. The immediate concerns were about espionage, or about the delivery of weapons. Our president at that time was Dwight Ike Eisenhower, a hero of World War II, someone who seems to many of us more and more sensible with the passage of time. But in his own time, he was often thought to be a lightweight who spent inordinate amounts of time fishing and playing golf. The launch of Sputnik further undermined confidence in Ike Eisenhower, especially since he seemed to have misjudged the public's reaction. He offered a surprisingly temperate response to Sputnik. We have subsequently learned from declassified papers that he knew well beforehand that a Soviet launch was imminent, was advised that Sputnik posed no immediate dangers, and was frankly pleased that the Soviets were treating space as neutral territory and the launch as a scientific rather than a military enterprise. Still, the public was skeptical and worried. Its views of the famously golf-loving president were put in reverse, not quite with the skill of John Keats, by the Democratic governor of Michigan, Soapy Williams. "Oh, little Sputnik, flying high, with made in Moscow beep, you tell the world it's a commie sky and Uncle Sam's asleep. You say on fairway and on rough, the Kremlin knows it all. We hope our golfer knows enough to get us on the ball." With time, Sputnik came to be viewed as evidence for an inherently exciting idea, that man is not earthbound. But by taking a first step toward space travel, the USSR had also demonstrated a kind of scientific preeminence. Although Sputnik was small, only about 190 pounds and essentially empty, it was a lot bigger than the first planned US satellite, which was to be about 3 pounds. In addition, a month later, a much larger Soviet satellite weighing 1,100 pounds was launched into orbit, where it remained for over 3 months. Sputnik raised some pragmatic questions for the US government. Should space be controlled by the military or by civilian services? And a year later, the Eisenhower administration wisely created NASA, a civilian space agency. Should the US undertake yet more ambitious plans in space? In my senior year in 1961, John Kennedy pledged to send Americans to the moon, and we landed there a mere 8 years later. Should the exploration of space be conducted by human beings or by robotic probes? This is a question that's still a heated one today. Now, a more general question posed by Sputnik turned out to be especially significant. Was the USSR becoming the dominant power in science and technology? In an effort to avoid that, the US dramatically increased its investments in science, in education, in training, and in research. Now, none of this seemed to have any immediate effect on my own aspirations here at Amherst College. If anything, I moved away from science and medicine, more heavily influenced by Ben DeMott, by Bill Pritchard, and others in the English department. But several years later, after I had reverted to and graduated from medical school, I had an unusually late exposure to research at the age of 28 at the National Institutes of Health, where I was inspired to pursue a scientific career. Now, this happened because the Vietnam War compelled me to perform military service or government service of some kind, and a choice between research at the NIH and military service in Vietnam was not a difficult one. At that time, in the late 1960s, the influence of Sputnik was still in play. Abundant funding for science, a partial legacy of the launch, made a transition to independent scientific work relatively easy, even for a young physician who was schooled mainly in English literature. Sputnik and the Cold War were spurs to federal funding of American science in that era, just as European competition for intellectual supremacy was a help to Herschel in securing money for his telescopes from the treasury at Windsor Castle. But what does this mean for those of you who now aspire to a scientific career, or to those of you who will aspire to one after being exposed to some of the great science teachers on this campus? This has to be a matter of concern. Funding for research and training has been static or in decline across scientific disciplines in the U.S. for the past several years or more. Our country's in the midst of a serious recession. We're waging 2 wars. Congress is in partisan gridlock, and the administration is considering budget cuts to halt further growth of a national debt. One of our best bets is our enlightened president, who views science and technology as the means, perhaps the only sensible means, to achieve the world's aspirations. Its aspirations for alternative energy sources, for better health, for reversal of climate change, for environmental remediation, and for economic revitalization. But as President Obama knows, science also needs another critical ingredient for success, namely a love of discovery itself, driven by curiosity, regardless of practical applications. In 1955, after his first 4 years as a teacher at Amherst, Ben DeMott was asked by the students who started with him as freshmen to speak to them at their moment of departure. He began by disabusing them of some of the purely sentimental reasons why they might be sorry to leave. For instance, he said that any emotion of regret should not be ascribed to the idea that the time in which you led the life of the mind is now coming to an end. On the contrary, he argued, the life of the mind, once begun, ends only in the grave. And for many, the life of the mind does not begin until after college. For under a complex academic curriculum, he continued, the student is more likely a victim than a free agent, and the life of the mind is one that can only be successfully led in the state of freedom. But if there's an inherent tension between the institution, Amherst College itself, and each student, he also argued that the college he had come to know here, and the one I also knew, was one in which, and I quote from DeMott, personal connections are somewhat more vividly realized than in many institutions, and the massive abstraction of the institution did not engulf the relations of individuals. So to you, who are now entering this institution 55 years after DeMott's farewell to his first seniors, I hope that this is what you will also find, that close relations among students, between students and faculty, will encourage musicians to become astronomers, pre-meds to become literary scholars, and everyone to exercise that wide-ranging curiosity that can be personally satisfying and perhaps also, on occasion, beneficial to others. Thank you very much, and enjoy your years at Amherst. Happy to take some questions and try to provide some answers if anybody feels inclined. I know it's hot in here. I'm hot up here. Tony's hot. Question on the left. Hi. That's where the monitors used to stay and take attendance for those of us who had to attend chapel.
So, in my experience so far at Amherst,
One day.
I'm not a first year. There seems to be a noticeable disconnect between people who have an appreciation for the sciences and people who don't. Namely, like people I've talked to who, they vow to never take a science class or math class ever again after they've got the open curriculum. And that seems to be most prevalent, more than people who seem to like to dabble in both. And I was wondering, why do you think that is, and how do you think we can rectify it?
Well, that's a tough question. You all hear that? The question is, how do we get more students learning about science, and try to put an end to the disconnect between those who are in the arts and those in the sciences. I don't have any simple answer to that question. I came to Amherst at a time when the curriculum was at the opposite extreme of what exists today. Not only did we not have an open, totally free curriculum, we had what was called the new curriculum, an invention that required all of us for our first 2 years to take essentially the same courses, perhaps one elective a term. So everybody in the class took physics, calculus, chemistry, as well as English, history, and other things, philosophy. And I found that okay. I know that's an unpopular notion with most of you and actually with a lot of the faculty. I think one thing that could be helpful, one thing that I know Amherst has done in the past, and I don't mean to be preaching about the educational theory, I don't teach at a college, but I think there's a virtue to impressing on everyone who's here the way in which the arts and the sciences intersect. For example, to devote a week of campus life to a major contemporary issue. It could be stem cells, it could be AIDS, it could be improve development of impoverished countries through a variety of devices. To take some central issue and show how our understanding of humanities, of politics, of science, technology have an impact on some major issue of the day as a way of bringing people together. I offer that as only one possible suggestion. There are other ways to do it by having disciplinary requirements that include, I think, exposure to a lab is a very important thing. The problem with exposure to a lab traditionally is that it's hard to make that exposure something that actually teaches you about the feeling of being in a laboratory and trying to answer a new and difficult question. I used to dislike my laboratory experiences as a college student because they were cookbook. And it wasn't until I got into a lab at the NIH and realized that there were frontiers all around me and I could be doing something in a laboratory that was actually answering a new question that I got genuinely interested in science, not because I wanted to know what was already known, but because I found thrilling the idea of working to discover what wasn't known. And if there's some way to try to do that, I think there are ways, then I think science will become more attractive to some of the undergraduates who think science is terribly hard, they don't have the aptitude, they've already passed AP, physics, and chemistry, they don't need any more science. There is a way to teach science at college that I think opens up opportunities to students who may not think they have the aptitude, but suddenly see that the excitement and the opportunity for discovery is still tremendous. Yes?
Hi.
You're a real freshman.
I am a
first
freshman.
year. First year.
First year.
Good.
Freshman.
Okay.
It's all the same.
No
Do you believe, I mean, you took a kind of a wraparound route. You took an English major and then went on to do pre-med and medicine and all that. Do you believe that your English major was essential to your life path and going on through all the medicine? Or do you wish you'd gone back and done pre-med instead?
Yeah, well, I did do pre-med when I was here. I just didn't do very well.
Okay.
C in organic chemistry, I'm proud of it. I don't think any of us can think that way. I don't want to think about my training in English literature as something that was useful or essential for my career. It obviously helps to be a reasonable reader and writer and speaker, and you learn some of those traits in just writing and trying to appreciate what the words on a page mean. But I think you should do English literature if that's what you find interesting at the time. And, life is long these days. People live to advanced ages, and I think a prolonged adolescence is generally a good thing. Not in a rush. Very few people go directly into graduate school or medical school, and there's no need to feel that you've got to be on a track at day one.
So what brought you back to medicine?
Pardon me?
What brought you back to medicine?
That's a tough question to answer. Part of it was just a feeling that I might not be as well suited as I thought when I was in DeMott or Bill Pritchard's classes at Amherst. Part of it had to do with the feeling that I was neglecting a part of my intellect that was actually interested in medicine. Part of it came from reading Freud and being interested in psychiatry all of a sudden, although that didn't end up going very far. But nevertheless, there were just other things that I thought, I was inspired by Gertrude Stein saying that medicine opens all doors, and I wasn't really sure what I wanted to do. I thought medicine is sort of a good holding place. I had a family history. My father had been a physician, and that had some hold on me. My parents actually were unhappy with my vacillations. They saw me finish college, not sure what to do, go to graduate school, and then decide a year later I wanted to go to medical school. They found this perturbing. One of my medical school admissions officers thought perhaps I should go to the Army and get more mature. There were various responses to this change of heart. But question.
Yes. I'm a first year again. So looking back, what do you think? What did Amherst give you that you appreciate the most? And
Getting away from Richard Holmes, aren't we?
yeah. And what suggestions do you have for us first year students?
Pick classes you genuinely want to learn something from, and don't worry whether it's hard or easy. Just get in there and take something that you think is going to be challenging and open up new worlds for you. Lady in the first row.
Me? Oh, yeah.
Yeah, that's you.
This is a dumb question, but in the book I got confused by its explanation of the sweeping process, and I'm wondering if someone can explain what that is.
Yeah, well, what they were doing is moving the telescope through the sky.
Just kind of like go up and down, so eventually
yeah.
it's like a zigzag.
Now, the problem that you have when you're an astronomer and you've got a powerful telescope, especially in those times, was to have the right degree of magnification. Because if the magnification is tremendous, you only see a very small arc in the sky. And in fact, some people found it amazing that Herschel was able to find Uranus because he had a very powerful scope and wasn't able to see very much of the sky at once. You find out with binoculars, you see a lot of the sky at low resolution. As you increase the resolution, his scopes became quite powerful, as you saw, 800-fold, 1,000-fold. You see a very small arc. But you do a gradual sweep, and when you get experience, as William and Caroline did, you begin to recognize parts of the sky. They would not have found everything that was there to be found, because they specialized in the parts of the sky that they would sweep every night, looking for new things that were swimming into the areas they were familiar with. But they also tried to map out as much of the sky with major stars as possible, because that was an important activity for astronomers. It was what made navigation possible, because as the panoply of stars got filled in by observers, it became easier and easier to navigate, determine longitude, and so forth. I'm going to take one or two more because it is hot, and I think everyone's getting a little restless. I know you've got other activities tonight, and so do we. Take one question from the balcony up there, in the back, that's you, and then one from down here.
So, when you were in school, you focused on English.
I can't hear you, you've got to speak a little louder.
When you were in school, you focused on English and then on medicine. And when Herschel focused on, he was intensely focused on music and then on astronomy. Do you think it's better to be intensely focused on one subject at a time, or do you think that, say, if I wanted to do go into science and English, could I do that?
Well, one of the greatest things about being at Amherst College, you take four courses, and you're going to focus on 4 courses. And I think that there's a great advantage to spreading your wings fairly broadly, especially at the beginning, and try things you don't know much about. If you haven't read poetry seriously with a great English teacher, take a course in poetry and see what it's like. If you've had some background in science, you may think that your AP courses have satisfied your need to learn at some high level, but I guarantee you that when you take a college course that allows you to read the primary papers, not textbooks, and talk to people who are actually working in laboratories, you're going to get a very different experience than you had in high school. I would urge every one of you to have that experience as well. You don't need to be focused at this point. You can be a generalist for a couple of years and explore something. The great thing about going to college, something that William Herschel never did, is that you have a chance to interact with both students and professors who have many deep skills and the instinct to teach, and you should take tremendous advantage of that opportunity. Last question down here. Sure.
In Holmes's book, he describes very extensively how governments funded scientific progress. And you mentioned today how the United States only began to really move into funding science and technology after we thought the Russians might become more technologically advanced.
Can I just make one slight correction here? What I was saying is there's an incredible increase in funding. But your point is a good one, because the government of the U.S. didn't fund very much science until after World War II. World War II was a great stimulus to funding of science because suddenly the government saw, and actually FDR was important, so was Truman, in recognizing that science provided treatment for malaria, radar, atomic bomb, other things that were very important to the nation in time of war. But go ahead.
So my question basically is, now that the United States is the preeminent scientific dominating power in the world, how likely is it that we become complacent and let ourselves lapse and let someone else catch up?
Yeah, well, people are catching up. There's no doubt about that. I would say we're probably leading in most sciences, but not necessarily in all at this point. And the reason it's happening is that, first of all, there's a good thing. There's a lot more science being done in Europe, in India, in Japan, in Southeast Asia, China. This is a good thing. Science is a leveler. Science provides a universal language, brings people together. Scientists work collaboratively
across nations. It's a peace promotion process for the most part. That's a good thing. On the other hand, there are tremendous economic and strategic advantages for America to be strong in science. And in my view, over the last decade or so, we've lost some of the lead we've had. Part of the reason right at the moment is the recession. We are in trouble financially. Part of it is the distractions of other activities, especially our unfortunate wars in Iraq and Afghanistan. And what we need, and we have in Barack Obama, in my view, and I'm a partisan as you heard, is a leader who understands that science is essential to the nation's future. But at the moment, in part because we've let the teaching of science slip in our K-12 system, in part because we are not funding the training of scientists with sufficient vigor. We're not providing enough opportunities for people like me, who didn't have a rich scientific background, to get involved as independent scientists, because funding for new investigators is often tough. We're just not providing enough encouragement to the many people who see the extraordinary opportunities that exist. I haven't had a chance to talk about what's going on in my own field of science, but I can tell you that I've never seen greater opportunity for being a scientist and making discoveries that matter for our understanding of how cells and bodies work, and from making progress against many diseases than I do today. But the opportunities to get involved are more limited, and unless we crawl out of this economic climate and get the nation, which is frankly divided in a partisan fashion in a way that is much more profound than anything I've seen before, unless we have that unification over some issues that we can all agree on, one of which is science and technology, we're going to lose ground to many other nations that see the potential in science. And the stem cell controversy of last week is only one emblem of that problem we face today. Thank you all very much. Enjoy the rest of the
I want to thank Dr. Varmus, who has given us much to think about. Amongst those lessons, to urge us all to follow our varied pursuits and varied possibilities here, as he did, to follow your passions into the courses that may seem more challenging, not to think that you have a set plan, and not necessarily to follow the plan that you have set. He's reminded us that poetry and science are not opposites, but powerfully interact. The faculty at Amherst is here to inspire you in the same lesson. George Greenstein, our own astronomer, was here for tonight. I see Carolyn Goot in the back, other great scientists here. The college, for instance, to demonstrate that combination of science and poetry, has this year as two of its prize Simpson lecturers, one of the nation's great astronomers, Professor Merio, and the greatest living poet in the United States, Richard Wilbur. I urge you to take their courses and the courses of all of the great Amherst faculty. But lastly, I hope you will think about that image that will stay with me. Most powerfully, I think, from tonight, that moment looking out on the quad, trying to find Sputnik going across the previously familiar and now not familiar sky. During your time here, history will happen. I pray it will be inspiring and moving history of the sort that Sputnik ended up being, though there may also be more tragic moments of history, as we have seen in recent years. Think about that history. Talk to each other about it. Go out into the quad and look up into the sky and try to imagine how the world and the universe has changed and keeps changing to inspire you to do what Amherst has brought you here to do and what Harold Varmus has done. Go make your own history. Good night.